Welcome. Today, the webinar is State-of-the-Art Biomass Heating with Froling Boilers with Scott Nichols, the president of Tarm Biomass in Orford. And I wanted to tell you that we have other webcasts coming up here. We're actually sort of doing a boiler review. Scott won't be too happy. We're talking also about the main energy system boilers next week. And then the Schmid boilers from Switzerland, which are a big line of boilers, the bigger 1 million BTUs and so forth. And then something having to do with Schmid, as a matter of fact, that is one of their projects they did over in Europe. I wanted to have some European projects just to show some differences. I think there's sort of different approaches they have over there and slightly different technology. So that should be a good one and an interesting one. In particular, they have steam boilers that are in food processing. So I think you'll find that will be intriguing. It is a small district heating system as well. I think they're going to do at least one other installation, and that will be to be determined at this point, but they're working on that presentation. So those are all on Thursdays in November. All of these are at 10 a.m. starting in November. We're switching from 3 to 10. So just be aware of that, and we'll be telling people about that in reminder emails as well. I want you to know that we do have a YouTube channel, which seemed kind of weird for us initially, but it's a great place to give people access to our videos, which are mainly our webcasts that we've done in the recent past. So especially I point out that top one, the role of forest biomass-based energy in addressing climate change. If you're interested in biomass and how it fits into the big picture, I just strongly encourage you to watch that video if you haven't seen it. And if you have seen it, and it's easy to pass that on to tell somebody else about it. I think there's a good amount of negative thinking on biomass when it comes to climate change and the thought that trees pull oxygen out of the atmosphere. And, there's a lot of data that we can talk about in that, but this addresses it in a very straightforward way, having to do with how especially we use our forests here in northern New England. We're not trying to heat Boston. We just want to be a part of the plan. And I think you'll find that with this explanation that you'll end up understanding how it is a truly viable part of the plan, where we're heating schools and all sorts of interesting rural installations, different buildings of different types. And it truly makes a lot of sense. So you could say that's kind of biomass propaganda, but you know what? It's science. It's peer-reviewed science. And we just love the fact that he's come up with this rationale that I think is fairly universal and very understandable. So today we've got, again, this is the state-of-the-art biomass heating with Froling boilers with Scott Nichols, and they are the U.S. distributors for Froling boilers, which is an Austrian boiler company. First, I want to tell you about Froling Energy. If you don't know about us, we're a mechanical contractor. We're focused on the installation of high efficiency, low emission commercial biomass boiler systems. And you'll find that we also do some residential, but that's kind of a sideline for us. We usually get into the larger boilers for big high schools and campuses and so forth. You'll see schools, commercial buildings, industrial buildings, residential homes, multifamily buildings. The multifamily, I think, is a very interesting one, the Applegate Apartments there over in Bennington, Vermont. A lot of good things to say. We don't have any particular webcasts about these installations that you're looking at here, but I think we will be doing some more specific ones that talk about the different types of systems we've done and sort of a variety that'll be coming up probably after the first of the year. We're a self-performing contractor. In other words, we can, if you say we need a new boiler building, we're going to have to put in some pipes to get into the main building. We've got some redesign in the boiler room, and we have to put in a brand new gas boiler and all these things. We do all that. If it's focused on the heating system, that's what we do. That we don't want to get involved in installing windows in a building or something like that. That's just not our thing. But when it comes to mechanical systems, and even construction of a boiler house, that's something we're pretty good at. And we've just done our most recent one, in fact, up in Campton, New Hampshire, at an elementary school there, where we put in a big dry chip boiler system, built the boiler house behind the school because there was just no room within the boiler room, and that's what we do. We take charge of that aspect of things. We do technical consulting on biomass boiler systems. So in other words, project development, and this is within our region where we'd be interested in working. But we actually find people calling us from Canada or out west or something, and they want some sort of initial advice on what we've been up to. And we're happy to do that too. It's obviously, not as an emphasis for us, but, we're in some ways sort of the proselytizers of the biomass side of things, and especially the dry wood chips, which is a sort of a neat technology. So there we are, design, project feasibility, estimating, value engineering, specifications, that's really where we are. And the last thing is we're manufacturers of something called PDCs, which are precision dry wood chips. They're bullwood chips. In other words, the core of the tree, there's bark, but not a high percentage of bark. We screen it and we dry it to 25% moisture content. And in doing so, we're able to deliver this by a blower truck, whether it's a blower semi or a fixed body truck. We have both, and we're able to push it through a 6-inch hose up into the top of an above ground silo. So it's sort of a game changer when it comes to larger installations using wood chips, which can be more economical by far than what wood pellets are. So it's a very competitive fuel, even at a time of low oil prices. So today, again, state-of-the-art biomass heating with Froling boilers. Scott Nichols is the president of Tarm Biomass. He obtained a BS in business law and public policy from Syracuse University, and he returned to Lyme, New Hampshire in 1995 to take a leadership role in his family's home heating business. Now, under his leadership, Tarm has diversified its thermal offerings and expertise while retaining a commitment to best practices for biomass combustion, which includes chunk wood as well as pellets that obviously evolved over time. This extensive experience in the various applications of wood heat, as well as his commitment to consumer education, has significantly contributed to the rapid growth of Tarm Biomass, which is great. Scott's one of the 9 founders of the BTEC, the Biomass Thermal Energy Council, and he's on the steering committee for the Heating the Northeast Conference and Expo, which we used to have all the time prior to COVID and so forth. It was a very good expo to go to learn more about biomass. He's also an advisor to the Alliance for Green Heat. So I'll tell you, when he's not working, which he's doing all the time, it seems, mostly, but he spends time with his family and friends, and he's in a lot of sports, skiing and so forth. He's also working in his wood lot. I guess he loves that more than anything else. He'll have to tell you more about that. He's got a wood boiler, he's got a pellet boiler, and a 4-panel solar array on his roof. That's for solar thermal. And then he's got a 2.5 kilowatt solar. This is like an energy guy. So the guru of Froling boilers, here he is, Scott Nichols. Scott.
Hi, everybody. I'm going to start by telling you a little bit about us. By the way, thank you very much, Jim. I appreciate you guys hosting these webinar sessions. I think it's great, given that we have such a hard time getting together as an industry now and bringing customers in to see us all as a big group. At least this gets a few of us together and some new faces and new ideas together, thinking about how to heat with wood. I appreciate you all signing on as well. Tarm Biomass, some of you know us, some don't. Some of you, I noticed, are our customers. I think my mother's on the phone today, my mom. I was joking with Jim before this started that we could call this Mom and the Engineers. It's a pretty good rock band name. So anyhow, Tarm Biomass, really you could explain us by what we've seen and what we've been through. Since 1995, a lot of things have happened in the energy world. A buddy of mine said the other day, showed me some slide of what the energy mix is going to look like 30 years from now. And I told him, just throw that out the window. We really have no idea what the energy mix is going to look like, because we have no idea what technology we'll have available to us in 30 years, and what the cost will be, what the relative cost will be. So anyhow, without further ado, we've seen a lot. I'm not going to read to you what we've seen and been through, but it's a lot. And primarily, I would say that the undercurrent to all of the stuff we've seen and done is the price of oil and gas. That is the biggest competition for biomass. So some of the highlights of Tarm Biomass. we've been importing and distributing boilers for 25 years as of this year. I believe it isn't cocky or arrogant to say that we started the residential bulk fueled residential pellet market. We were on the boiler side. New England Wood Pellet was on the bulk delivery side of things, and the two of us worked together in the beginning. In 2009, we introduced the first fully automatic pellet boiler in North America, followed by others soon after. In 2013, we were the first suppliers of dry wood chip boilers, and very similar to the introduction of wood pellets, we were lucky that a couple companies started at the same time providing dry wood chips. Froling Energy being the biggest and most important partner of ours. Along with all this new stuff that we do, we still support boilers that are 40 years old. And a lot of the time I spend on the phone is actually with some of my old customers, which is a great pleasure of mine. One of the things that might be confusing to you all is that Froling Austria and Froling Energy are two completely separate companies with no relationship except through commerce. It just happens to be a last name that was common enough that two people in the biomass energy started companies. So no relationship between Froling Austria and Froling Energy, which is owned by Mark Froling. So I'll start by telling you a little bit about Froling Austria. Froling is perhaps the largest biomass boiler company in the world. Certainly among the biggest. They only do biomass, and they pretty much only do tree energy. In other words, pellets, chips, and cordwood. They have a large range of boilers. Sometimes I feel like we have an elephant by the ankle doing business with this company because their product offering is so broad and is so far beyond what we can provide markets for in North America that it's stunning, actually. But they make heating boilers. They have a thermal storage plant in the former East Germany area, a tank company that was actually in business back in the communist days, and more recently ventured into combined heat and power. They export 80% of their products. They are located in the state of Upper Austria, which is a state that's about the size of Massachusetts with a similar population. Why is all this important? Well, really, it's not to you, except that they have been in the North American market for 12 years. They do business with us and also with a couple Canadian importers. They make their own ASME models, so they have their own ASME shop and their own certified welders. And they have 8 models that they're currently exporting to us, which include multiple sizes of cordwood boilers, wood pellet boilers, and wood chip boilers. Before I get into technology, I just wanted to, Jim titled this presentation State of the Art. And I just wanted to point out that what I've learned in 25 years is that state of the art is as much about equipment as it is about the process of installing and maintaining that equipment. And so that state of the art even involves people like Khalid, who are here partially because of his work with the state of New York, for instance, making sure that boilers are installed correctly, so that not only are people happy with them, but they produce low emissions as they're supposed to and don't chew up excess fuel. So this is all about right-sizing equipment, providing the best fuel feeding mechanisms, making sure that fuel is the right fuel for the job, and then competent installation and service and the consistent providing of fuel. And Froling Energy is one of the best companies in the United States for this, because they not only can design a system, but they can put it in service it, and they provide, in the case of wood chips, their own fuel. So that's really important, having happy customers and a successful installation. So when it comes to state of the art, I'm going to point out what's happening now with boilers primarily. And what we see coming from Froling is ever more compact boilers. They are finding ways to do more things with fewer moving parts, more things with fewer motors. So instead of using a motor for two jobs, sometimes they're connecting the two by a cable or a linkage. We are seeing them including electrostatic precipitators in the boiler body itself to reduce emissions while keeping the footprint tiny. That's definitely a trend we're seeing. As I mentioned, Froling is working very hard on combined heat and power at a commercial scale, not at a residential scale, which and I'll talk to you about this in a little bit. And then over there in their home markets, they've had a very popular combination chunk wood and wood pellet boiler. Unfortunately, that machine would have to be over $20,000 if we were to sell it here, and we just don't think there's a market for it. So that is not something we sell. Technology trends, as I mentioned, more compact boilers. Froling is putting a ton of emphasis on reduced electrical power consumption. So all of their fans are being reassessed, it seems. Their induction fans and forced combustion fans. They're smaller, they're quieter, using less power. They're adding condensing features to their boilers whenever possible. At first, they started with condensing heat exchangers that were tacked onto the boiler. Now they're integral, and I'll show you what those look like a little bit. At first, their boilers had some heat exchange passes that were not actively cleaned. More and more, those surfaces are being actively cleaned, which to me is a major advantage. As I mentioned, integrated ESPs. They are combining drive motor functions, and I mentioned cables and levers, but they also are using cogwheels a lot. So you might have 4 augers driving off of one motor. And that does a couple of things. Number one, it means you're less likely to have a motor failure because gears are pretty reliable, but it also means you're reducing your power consumption. So they're doing things like adding larger airlocks, tons of fuel feeding options, and I'll show you a few of those. Touch screens are a big deal. To me, that's kind of nice for the consumer, but they're not all that helpful, actually. I don't believe. I think too much emphasis is put on that stuff. Applications to monitor the boilers, again, pretty neat. How useful is it? I don't know. You know, if it tells you that there's a fault on the boiler or something you need to correct, that's great. But there's a little bit too much fluff for my liking. Same with the LEDs. They're putting LEDs all over everything. And as it says on the slide, that's pretty much about, looks excellent, dude. Keep it up. Marketing. So less ash handling and CHP, which I believe is primarily for marketing at this point and experimentation. It's not a real economic driver. I'm going to start by talking about pellet boilers and small pellet boilers. This is a pellet boiler that Froling Energy recently installed at a church in Peterborough. And this photo is interesting because this is a 120,000 BTU per hour boiler that is in a 3 by 3 foot square area. In other words, the footprint is 3 feet by 3 feet. This red box in the back is the vacuum. So Froling used to integrate that vacuum into the boiler body. They now make it so that it can be mounted anywhere, which is handy in terms of service, and also if you are in an area where you need to have really quiet operation. That vacuum is the noisiest part of any automatic pellet boiler, and it can be moved to an area where it is muffled, which is great. This tall silver device is a dust cyclone, and normally we wouldn't install a dust cyclone with a small boiler like that, but we do provide those as standard parts with any boiler 100,000 BTUs and up. And what those dust cyclones do is they mount on the return air line from the vacuum, and they take basically the flour out, the wood flour out of the system, so that you don't end up with clogs in the bin primarily. We usually don't see clogs in the boiler, but you can get clogs in the bin, and that dust cyclone will go a long way to improving that situation. So one of the biggest changes we've seen, at least on the residential level, but yeah, commercial level too, is making boilers more compact. And I don't need to linger long on this because you can see with your own eyes what the difference is, but it's substantial. And the other thing is you can see that there's more than a halving of power consumption from the older boiler to the newer one. So all these little things add up. They're not in any one case groundbreaking, but they're all little improvements that take a lot of engineering. So this is what the interior of that pellet boiler looks like, the new one. The fuel is vacuumed in to the boiler. This is the day bin here at the top right. The fuel is augered out of that bin down a drop tube into the combustion chamber. This grate here retracts, it slides back and forth. So every time this boiler shuts off and then reignites, it's starting with a fresh bed of fuel by taking the ashes off of that grate. As with boilers that have dated back to the 1970s, this boiler is configured with a burn chamber in front, a heat exchanger in back, and there's a hollow drop area underneath all of them for ashes, and a common ash auger sends the ash from both chambers to the front to basically a small travel-sized suitcase, metal suitcase, and that would be taken out 3 to 5 times a year. All of the areas of heat exchange in this boiler, with the exception of the firebox, which doesn't build up ash very much, are actively swept. So these are the heat exchange tubes in the back, and they are cleaned by these turbulators, which slide up and down, and they are on a motor, which lifts these turbulators and then drops them percussively to shake off the ash as well as scrape. So what else? Outside air, a direct outside air connection is possible. I noted this ceramic resistance igniter because it's another element of power reduction that they've added in recent years. They used to use a 1,000 watt Leicester hot air gun on these boilers, and now they use this 400 watt ceramic resistance igniter. So they're doing whatever they can to reduce power and make these things more efficient. This slide is the best. I know it's a little fuzzy, and I apologize for that, but it was the best I could come up with, showing the new condensing features and the built-in ESP. So on the right-hand side, this little sawtooth red object is the electrostatic precipitator. So this is an ash grabber. These little yellowish acorn-looking things are actually sprinklers. So what you have here is you have ash grabbing here on this ESP. You have down below, these are actually, you see the turbulator lifters. So these arms are attached to the springs that are in the tubes themselves. Those tubes scrape up and down, and all of the ash that is condensing in these tubes, because there's moisture in there, occasionally gets washed with these nozzles, spray nozzles, and that ashy water comes out at the bottom, goes out a drain and into the septic system. I have major questions about this technology, especially in rural places where people have private septic systems. I think probably having ash going through drain pipe is maybe not the best in the long run. And when I've asked Froling about this, they do not have the answers. So this is an interesting technology that is being driven by incentives in Germany primarily, and is forcing, in my opinion, a technology that may be very efficient but may cause long-term problems, especially in rural places where their septic system and the drain pipes can't handle all that mud. But very interesting, it increases the efficiency about 10%. So in the long run, if we can come up with a way to solve that mud issue, I think I can't see why every pellet boiler wouldn't have this technology. Because we have limited time, I'm really giving you a high-level view of new technology. And if anybody wants to reach out to me afterward to speak about any one particular aspect of what I've showed you today, please do so. At the end, I'm going to provide you with my phone number and email address. So I'm going to go fast, and I apologize for that, but I wanted to show you trends and primarily new stuff. Here is an image of a T4 dry wood chip boiler. Froling Energy has done quite a large number of these, primarily in schools, a little bit of manufacturing, and I believe maybe, if not them, then one of our other dealers has done some multifamily homes with these. But this boiler is fairly unique as a dry wood chip boiler. And why would you choose dry wood chips over green wood chips? Well, one of the biggest things about dry chips is they can be conveyed more easily, which Jim spoke about. They can be blown through a hose. They're light compared to a green chip. They don't tend to mold and clump as much as a green wood chip, so you don't need such heavy feed mechanisms, belts, for instance, and they can be stored outside and they won't freeze into clumps. So you can store them more in more applications, and you get smaller machinery. So this boiler is actually pretty compact. It's about 7 feet long, 4 feet wide, and 6 feet tall, makes 500,000 BTUs an hour. And the reason it can be compact is that you don't need a massive combustion chamber with all sorts of brick. You can have a good hot burnout with a fairly small refractory area in the boiler, and then accomplish all of your heat exchange in that one small area and still have good efficiency. So for schools with limited footprints, in the boiler room and out, dry wood chips make a lot of sense. So in and of themselves, dry wood chip is a sort of growing and state-of-the-art idea in North America. It's well known and tried and true in European markets. But in the dry wood chip boilers themselves, we are about to be able to offer a bigger one. We've had a 500,000 BTU per hour model. We will next year have an 850,000 BTU per hour model, which is only 1 foot longer from front to back. And it will have the optional built-in ESP. So it'll be bigger, it'll be cleaner. It has a really nice feature that we have not had on our current T4 wood chip boiler, which is that the first pass is now actively swept. The philosophy from Froling initially was that this tube here was had a high enough, or bank of tubes, I should say, had a high enough velocity that ash would not collect there. But we are finding that with some fuels, maybe more bark than others or maladjusted fire slightly, you get a buildup of very cakey ash here that can start to block this tube and has to be hand brushed. So going forward, this will be actively swept, as will all the other tubes. So I see this this is a major improvement in terms of the serviceability of the boiler. As mentioned, it will have an ESP as a standard option. In this case, the ESP will be below the tubes. As the flue gases come down to the first pass, they're going to turn. They're going to go right by this ESP, where the fine particulates, additional fine particulates that don't fall out, will be gathered up by this ESP. Others that are caught on these turbulators will then be shaken down into the bottom of the boiler, and all of that ash is scraped and then augered forward to a common bin on the front of the boiler. What we find right now is that a boiler of this size produces enough ash that the ash box has to be emptied about once a week. We could make a bigger ash box, but it would be too difficult to move if it was made bigger and more heavy. About a week is about as much as a human can handle in terms of ash weight without having to get heavy equipment or special dollies and stuff. So that is one reason why we don't make the ash bins larger. They just become too heavy. I wanted to show you some of the capabilities of Froling Austria, not just with the boilers, but with their feed mechanisms, because any of you engineers who are with us today will know that one of the biggest challenges to putting a boiler in a building is managing the fuel. So fuel conveyance is a big deal, and having flexibility with that is very important. So if you have a space and you can't figure out how to put a boiler and fuel storage in it, let us know. Let Froling Energy know. Let the Austrian engineers get on it, because they've been doing this a lot and they have a huge number of feeding mechanisms at their disposal. Here's an example of 2 rotary chip feeders in a long skinny room feeding one boiler. Here's an example of over here on the right of a small room where one big diameter rotary feeder wouldn't work, but 2 small diameter feeders cover the complete floor space, also feed to one boiler. So there are lots of options in this regard. Also shown here, you may notice there's this tray with an auger in it. This is not something that's available in the US that I'm aware of. But it's basically a dump tray. So this vehicle can back up to it, dump the fuel into this tray. The fuel is conveyed to a vertical auger, so up a story or 2, and then there's a flail here that will flail the fuel into the top of these bins. You can sort of see, it's not really a good example, but you can see these flails here where my cursor is. But the bin is up high, which is kind of crazy. Here is another example of technology that Froling has added in the last year. And it doesn't look like that big a deal, but if you've ever tried to put a big boiler into a small school or a small commercial area, you know the fuel feeding can be a big deal. So normally when you have a big boiler like a T4, you have a rigid metal auger, and I'll show you a picture of that in a few moments. But it's basically another version of one of these. But they developed this system here, this vacuum system, so that rather than having a rigid metal auger that has to go in a straight line 12 feet, 15 feet or something like that, you can then, instead of that, just use this bin with 2-inch vinyl hoses the same way you can with a residential boiler. And they've come up with an airlock, so even though that this stoker is sitting right below the fuel, there's just absolutely no chance for there to be a fire moving through from the stoker to the bin. It's actually a double airlock. There's a paddle airlock here at the base of the vacuum bin, and then there's a larger cast iron airlock that they use also with their chip boiler. Here is another fuel conveying feature that I believe should be considered state-of-the-art. And this is a rotary feeder that would go in a round bin, just like here. This is that same rotary feeder. But rather than driving that rotary feeder with the auger that's removing the fuel, as is so typical, this would be the fuel removal auger. This one offers an additional drive for the rotary unit. The reason why you add an additional drive is that if you have fuel in a bin, as the fuel gets lower and lower, and your feed auger here is going at one speed all the time, it's going to get less and less fuel as the bin gets lower and lower. So what they do is they add this independent drive, and that way this rotary feeder can speed up the fuel delivery to the fixed auger. So this enables you to get full feed basically until the bin is completely empty, which if you haven't had a boiler running low on fuel before, it wouldn't be important to you. But if you have had calls like I have, hey, why is this boiler operating so funny? Well, look in the bin, the fuel's not getting there. You need to either add more fuel or next time put in an independent drive rotary feeder. I wasn't sure whether to include this photo or not. It's pretty hard to figure out what you're looking at here, but this is the inside of a chip bin. Here you can just make out the rotary feeder arm, but I wanted you to see that even with perfectly good dry chips, you can have a very straight wall of chips. This is a sheer wall of chips, and it's completely ringing the rotary feeder. So this rotary feeder was not able to knock these chips down. And there are two types of rotary feeders. One with a spring arm, it's just made with arms like the springs in a vehicle, like a pickup truck vehicle or heavy truck. This one is more rugged, and it has beam style arms with heavy springs and arms that articulate. And this would have tended to rip those shear walls down. So a lot of different options with feeding. Here's a good image of the spring arms in action, and here they're actually conveying pellets. A couple things for the engineers on the webinar to see if you aren't aware of this. This is steel cladding here. Without that, after the 6 years that this bin has been used, these arms probably would have cut through the concrete walls and the thing would have collapsed. So they don't look like they're very heavy duty, but they have sharp ends and they're pretty powerful, and they will cut through a bin. So it's good to think about what your bin size is and shape, and you know, if you're going to have a lot of rubbing, whether it's concrete or even steel, you definitely want to clad it so it doesn't get cut through. I showed you earlier a couple of different feed options, and this was an interesting one that I pulled right from Froling's literature. It shows a single boiler being fed by a single feeder with an independent drive. It shows two boilers being fed by a single rotary feeder with an independent drive, and then they show this with the extra long. And I knew there was a reason why they went with this extra long, but I could not remember. So I sent them this picture right from their literature, and I said, remind me again why you do that. Well, the reason is that as this rotary feeder sweeps this way, there's not enough fuel in this area where this red arrow is in the middle to supply the second auger. So they realized, whoops, you need an extra long auger if it's on the back end of the rotary feeder. So this is not state of the art, but this is what happens when you work with a company that's been around for a little while and has been through the wars. And that includes us, Froling Austria, and Froling Energy. Here are some photos of a T4 dry chip wood boiler installation that Froling Energy recently completed. This boiler is connected via a straight auger to the wood chip bin, which is behind this wall. The fuel is fed through this black channel. It drops down through a rotary airlock, which is I don't know what it weighs. It must weigh almost 100 pounds, cast iron valve. That valve is driven by the same motor that drives the stoker. So when this stoker turns to feed the boiler more fuel, there's a chain connected to the rotary air valve that is turning it accordingly, basically at the same rate. There is this feed auger comes here, and it also runs at the same timing as the stoker, and that timing is accomplished through the drives, the variable frequency drives, which reside in this box and are controlled by the boiler. This feed auger has a deluge valve at the top of it. So if for any reason you get heat through down the stoker, which is always sloped downward, and somehow up through this rotary air valve, if this area gets hot at all, this deluge valve opens and wets this entire area. There's a little peak site here that you can look in and see what's going on, service that, take out long pieces if they've made it that far. Anytime that door is opened, the whole system shuts off, actually. So this door causes us more problems on boiler tours. Forever people are walking by the boiler and opening those and shutting down the whole boiler. So it's a love-hate relationship, that door. This is the 500-gallon buffer tank installed at that location. Because this is a chip burning boiler with a fairly large, even though it's a small boiler, it has a fairly large fuel bed, and that fuel bed is hard to turn on and off instantly. The refractory around it weighs several hundred pounds. That does not cool down instantly. So when the heating load shuts off, this boiler needs a place to put that excess heat, and that heat goes into this 500-gallon tank. The boiler knows in advance how much heat is remaining in that tank. On the right-hand side here, you can see that boiler is sensing the tank with 4 sensors. It knows the tank temperature from top to bottom, and based on that, knows what percentage of heat or capacity, thermal capacity is remaining in that tank. And the boiler fires in accordance with that. So pretty intelligent use of the buffer. And that 4-sensor system is standard on all of their boilers, whether it's a small cordwood boiler, pellet boiler, or a large commercial boiler. This is what the outside of that installation looks like. So the boiler sits in that brown building. The black feed auger that you saw on the right of the former images goes into this big silver bin, which is filled by that big candy cane hose coming out the top of it through a pneumatic truck. The greenhouses behind the brown building are heated by that boiler, and as proof of concept, proof of heat, bang, there are the actual growing plants. This is in New Hampshire. Moving on from the T4, one of the big areas of emphasis for Froling and every other boiler company in the world, I think, is the electronics, the connected nature of the equipment. Last time I was at the ISH show in Frankfurt, for instance, Viessmann had an entire booth dedicated to their new software. And when I mean entire booth, I mean like a 5,000 square foot education center. This is a big deal, and I think that's good and bad. I think consumers really don't care about their heat. They just want it to work. And when we try to connect them, I think sometimes we make more of a mess for ourselves than we want. But this is the way the world is going, and so the heating companies go along with it. What Froling is doing is they are providing this Connect feature at no charge. And just like most of the apps that you get at no charge, this entitles them to learn a lot more about their products in the field. So they see the same data you see, and your customers see, and so maybe it's a rising tide that lifts all boats. For us, it's handy because we can see when there's a fault. If we have a customer who is wanting us to do service, we can see how many hours their system is run. I have on my phone about 8 systems. I don't know whether y'all can see that or not, but I have multiple systems on my phone that I can look at, including my own. I can see operating hours, I can see the state of operation, and I can see if there are any faults or any odd things going on. In Europe, where Froling boilers actually control the heating system as well as the boiler, they can turn thermostats up and down, change mixing point temperatures, so on and so forth. So way more functionality than we have. But anyhow, I wanted you to see that this is a major emphasis. And I think from Froling, we'll start to see more historical data kept as well. So more graphing functions and long-term information being available to both customer, service company, and manufacturer. From that, I'm going to go back to the boilers and show you Froling's, the largest boiler that we import. This is a TurboMap 500. This boiler can operate with chips up to 45% moisture content or wood pellets. And the only differences between this boiler operating with the 2 fuels is a different grate set. The air holes in the grate system are much smaller for pellets than they are with chips. And after that, there's basically control settings, but the combustion system is automated enough that it can figure out how to operate with very moist fuels or very dry fuels. So for you engineers, I saw some guys from Wilson Engineering and some others on the webinar. You will know that flue gas recirculation is essential when you're burning super dry fuels, so you don't overheat the boiler. This boiler monitors the combustion chamber side of things, can add case cooling when necessary, very automated. This is a machine that operates 24 hours a day, every day of heating season, all heating season long, without needing to shut off. It de-ashes every portion that needs to be de-ashed. The grate, the heat exchanger, everything, it does not shut off unless you want it to. So no weekly raking or scraping or brushing or review. It just runs. Like their other boilers, is quite compact. This 1.7 million BTU per hour boiler operates in a 10 by 12 foot footprint. One of the very unique things about this boiler is that for its size, it has a vertical heat exchanger. So on the left, the red section here in this photo is the combustion chamber, and on the right is the heat exchanger. This took them a long time to develop properly, but they wanted to do it because they believe, and as you would know, common sense tells you, that with biomass, vertical heat exchangers are a major advantage because of the amount of ash that's involved in the exhaust, entrained in the exhaust, I should say. So the beauty of this system is that they don't need a compressor to blow air out. They don't blow anything down. Because they're not blowing anything down, they're not blowing a bunch of ash into the smoke and blowing that fine particulate ash out the stack. So this is basically almost like having a multi-clone built into the boiler because there are so many passes of the exhaust in that heat exchanger, and they're vertically integrated, vertically oriented. All that ash falls out into the augers, which then convey it into boxes that are removed occasionally. So on the left here, you see that vertical heat exchanger. There are 2 large doors on top, basically trap doors. that one would use to access that heat exchanger on an annual basis. These tubes do not get hand brushed. I've spoken with our installers who put these in. They do not hand brush them. They're not seeing any problematic increase in flue gas temperatures. The turbulators in that heat exchange system are doing an adequate job scraping those down on a regular basis. Here on the right, you can see a top-down view of the heat exchanger. That's my boot. That's my pant leg. I'm standing on top of it. I've thrown open the big trap doors and looking straight down. This round area that my foot is on is this access port for the main transfer area of the exhaust gases. I'm going to finish up talking to you a little bit about the CHP system. This is not available in the US at this point. It's a very complex system. I'm not even sure how we would run this through UL past EPA if necessary. Testing and listing for such a machine would be, I think, a little difficult. But knowing that there are some pretty huge grants out there, if any of you on the webinar today can conceive of a place where you would like to see one of these put in, I would love to join an effort to apply for a grant from DOE, the Forest Service potentially, for a site that could use dry chips to make heat and power. So these CHP machines need to run at least 8,000 hours a year to be economical. So a typical heating season for a residence is probably 2,000 hours. Our most heavily used, worked at the red line, beat up boilers currently are running at about 4,000 hours a year. Just to give you a sense for how many hours 8,000 hours of load is, it basically means it's running all summer. So this is hospitals, this is wood products manufacturing where there needs to be active drying. It's best when electricity is expensive. They say 25 cents per kilowatt hour is where you need it to pencil out for your power. So limited applications in the US right now, but I'd love to get a demonstration project going. And I'll show you how these work in just a second. This is a wood manufacturing facility. They actually dry and sell wood chips just the same way that Froling Energy does here in Keene, New Hampshire. And they also have a wood pellet plant, so they're able to put all of their power to use as well. And as you can see, they have 6 CHP units all in a cascade. Froling has, I don't know how many of these systems out there, maybe 50, something like that. So it's small, but it's growing and they're learning a lot about it. So how Froling does their CHP is like some of the other companies out there, but it's pretty interesting actually. First of all, they found that they have a lot of trouble with wood pellets for this type of pyrolysis system because wood pellets tend to be too dusty. They tend to break, and that dust presents a problem for the gas. The gas is not clean enough. So they like to use basically a super premium dried wood chip. They try to shoot for 15% moisture content or lower. I don't know where we'd find that right now, but this is my point. It's unique and new, limited applications, but I'd love to get the ball rolling. The fuel feeds in here in the brown area, same way it does into any of our other boilers. The fuel then drops into this pyrolysis chamber, and the fuel then goes through a drying and burning out process, oxidation. The ashes from that first process drop out here. So in that regard, it's very similar to some of the other boilers, except that there's comparatively a lot less oxygen. The gas then goes through a first heat exchanger before it enters the primary heat exchanger. And you see here, there's a flare. And don't be alarmed by that gas flare. That flare is there because when this thing is initially started up, you do not have high enough temperatures to introduce those gases to the heat exchanger. They're very fuel laden at that point, the gases are. And if you were to cool them to the extent that Froling is cooling them, they would condense in the heat exchanger and make an awful mess. So until the system is heated up, until the water is at temperature and the pyrolysis section of the boiler is at temperature, they flare off the excess gases. So that is not something that's running continuously. It is only on startup, which is a very small part of the operation of the boiler. So after passing through the heat exchanger where they're extracting the heat for heating a building or a process, that gas then runs through a cloth filter system before it enters a gas engine. An internal combustion engine. They use MAN engines, M-A-N engines in Austria and Europe. But any gas engine like those you'd see in the US on some of the, you see them in, primarily I see them in municipal buses, natural gas, generally compressed natural gas. But that type of engine is all they're using to drive their generators. So in concept, it's quite simple. In process, it's not as simple. It needs the right application, and because of the complexity of the system, it needs to be run where there's an intelligent operator around who can service it, take the ash away, make sure it's running correctly. That is all. I have probably killed you with information and gone much too fast, and I apologize for that. But hopefully I piqued your interest a little bit, and you'll have some questions for me, and I'm happy to answer those now.
Sure, Scott. You know, everybody can go to chat, which is if you're looking at your presentation screen, just run your cursor around and you'll find it's probably at the bottom. Could be at the top. So find the chat bubble and put in your message to everybody here, and we'll answer your questions. You know, one of the things that I thought about here as you were talking about the different fuels is that we actually do have a video that I did, and that's on our YouTube channel, that compares the 3 biomass fuels and talks about systems. You know, it's generically about different systems, or I should say about some very specific systems, not all systems, but it gives you an idea of the differences of these 3 fuels and you know, some of the advantages and disadvantages and, you know, concerns and whatever you might have about the different fuels. So that's something, if you're just wanting to know a little bit more, especially this, you know, people seem to know pellets. They may not know, they know green chips a bit perhaps, and this dry chip thing is sort of an unknown, and it sort of goes between the two. One other thing I was thinking was that your T4, people often say, gee, you're like one of the few suppliers of these dry chips. Well, in a T4 150, you can actually put pellets in there as an alternative fuel. So if they should not be available for a short time or whatever reason, pellets can actually be put into that boiler to give you a secondary fuel without a lot of complications.
And many of them are operating on pellets, Jim.
Right, but I'm saying there's a pellet version, which is maybe lighter augers and such, and then there's the chip version, and the chip version can burn either. Right. The pellet version, because the augers are lighter, can't burn chips. That would be not typical. So if you're using a flex auger or one of the new pneumatic systems, that would have to be simply pellets. Yeah. And Scott's contact information in chat. Yes, I can do that. Anybody else have a question here? Scott, about those the big CHP system. So you're thinking that it would be good to find a project for that, and it would be, like you say, a hospital or something like that. And this could just be an experimental kind of thing where we aren't trying to heat the whole hospital. We're just trying to get this constant load. There's a number of situations, I'm sure. Can you describe where, you know, how you might fit that in?
Yeah, so the output of the boiler is on the heat side is 350,000 BTUs per hour, 100 kW. Basically need at least that amount of load all the time. And as a byproduct of that thermal output, it's making 50 kW of power right along with it. So any place that has a consistent thermal load, at least 350,000 BTUs an hour or larger, and consumes power is ideal. So any kind of manufacturing facility that has expensive power, any kind of, I don't know, there may be some remote locations, perhaps native villages where this might be interesting, where there might be, especially if there's a small district heating system, might be interesting. Yeah, at this point, of course, in the United States, our power remains fairly inexpensive. And our heat actually is also fairly inexpensive as well. So right now, there's not a demand for this kind of product, but I believe there will be in the future. And so I'd love to begin a demonstration project and begin figuring out how these will work and in what applications they'll work best.
As we're in New Hampshire, we're fairly close to that price when you consider the distribution fee as well as the cost of electricity. So right. Although you can buy it at a better rate when you're buying a lot of electricity. So here's a question. What are the standard buffer tank sizes for each boiler size? Is that included in the boiler specification information?
We include buffer tank specification for the residential boilers, partially as a result of our EPA approvals. But when it comes to commercial size boilers, we can only provide recommendations. What we've found is that with buffer tanks in commercial systems, sometimes unless you get past a certain threshold, there would actually be no reason to have a buffer tank. So a lot of the buffer tanks that are installed in commercial systems are way too small, and they do nothing except add cost, unfortunately, and complication. For instance, with a greenhouse, you need a much bigger buffer tank than you do with a building heating application, because a greenhouse will lose temperature much more quickly than a regular building will. So if a boiler has been off and is not hot, and there's a call for heat from the greenhouse, that call for heat is going to be immediate and substantial, and it will draw a lot of energy out of a buffer tank. And so with an application like that, you need a bigger buffer tank than you do otherwise. So we can certainly help make recommendations because we know how long it takes these boilers to get hot. But we do not, and how long it takes them to cool down, but we do not have specifications for the big boilers.
Here's another question. Bill he says he installed a kettle pellet boiler, which we've heard of before. He said they actually stopped importing these a few years ago, and he says he gets his pellets from Lime Green Heat for his 3-ton storage system. And his concern is, his question really is, what do you see as the long-term viability for pellet boilers? Perhaps pellet supply, I guess it's more of a supply question, honestly.
It's a great question. And I have, for about 10 years now, wondered about that myself. And the market continues on. What I would say about pellet boilers is that they occupy a very important possibility for renewable heating. Right now, we have very few ways to provide renewable heat. In this country, there are heat pumps and there is biomass, basically. Obviously, there is passive solar thermal, but that is very limited. Pellet boilers are important because they provide high temperature water which is especially useful for homes, older homes, or homes that have not been retrofit with updated distribution systems. And for that reason, I think we'll continue to see the utility of pellet boilers for the foreseeable future. Having said that, if we can figure out how to make heat pumps that provide 160 or 180 degree water with high coefficients of efficiency, then I think that pellet boilers become less important. But their pellet fuel as a fuel will remain for a long, long time because there are a lot of pellet stoves out there. So pellet fuel, I don't question it one bit. Pellet boilers, we'll see what happens in the long run with technology. But for the foreseeable future, I think they have a very important role to play in making heat renewable.
We always say when the price of oil goes down and you've got a pellet boiler or a pellet stove and you're trying to figure out what should I do, what happens is when oil say $2 a gallon or less, people start to say, it's just easier, I'll just use the oil. But what that does on the demand side and the supply side, I should say, the demand effect on the suppliers, they're sitting there with a lot of inventory. And if you get 2 warm winters in a row with low oil temperatures, something like what we experienced last year, and the lower temperatures even this year, lower prices even this year, that's really difficult for these pellet companies to survive because they're so ramped up and they have to be so reliable to give everybody the fuel that they need, especially on the bulk side. They can work all summer long and make the bagged fuel. And then when it comes to bulk, come January, they have a tremendous amount of load that suddenly has to be delivered and has to be ready for those delivery trucks to come in and fill up and go. Like one of the biggest manufacturers, or the biggest, I should say, is Lignetics, or the New England Wood Pellet Company in Jaffrey, which is just south of Peterborough, where I am. And, it's tremendous operation. And, we just have to say, keep supporting those guys. They're supporting the local economy and all that. So it's just a little biomass message here for you to keep it going, because that's really hard. I mean, that's how we would lose a pellet plant, is that they just economically, it's a tough deal. So keep them going. We have a lot of producers up in Vermont, and there's 1, 2 in Vermont, I think, and then there's a few in Maine and obviously north of the border. But the big one that supplies to just about all the schools in southern New Hampshire and Vermont is New England Wood Pellet. That's where trucks start out and fill up and go around on their delivery cycle. Here's another question: what is the boiler lowest turndown ratio before your pellet boiler cycles off? Perhaps the other boilers as well, Scott.
I don't know exactly, but generally speaking, it is 30% of the rated output. Each boiler can vary, but that is generally the lowest setting that you'll reach with a pellet or chip boiler before you start to enter a territory where you're not burning cleanly anymore. You might with a certain kind of fuel, a perfect chimney draft situation, fine-tuning the machine specifically for a test to be able to get lower ratios. But out in the field with a regular consumer and heating systems that are uncontrollable, 30% is about as low as we want to go before we say we should shut the boiler off.
Okay, here's some other questions that I think I missed. One is 4 tank sensors to 1 boiler. What if you have 1 tank with 2 boilers? What do you do? And maybe how does that impact boiler, I should say, buffer tank sizing?
Well, 1 tank with 2 boilers. Well, the way it works is that there is a master boiler that controls the system. So you could have, with Froling, up to 4 boilers in a cascaded system. And the primary boiler would be controlling the secondary boilers based on the tank temperature. So everything feeds through that 1 boiler. As the tank heats up, that controlling boiler is going to shut off the secondary boilers as the tank gets hotter and hotter. So that's how you control that. If you have one boiler with multiple tanks, which would be sort of the opposite situation, you'd put all the sensors on one tank because both tanks would normally be installed to operate with the same temperatures between them. They basically, even though they're two separate tanks, they'd have the same array of temperatures within them.
The piping on a buffer tank system, I think, is pretty important. You know, you've probably seen it. We've seen a number of different things. Sometimes they go in wrong, and you're putting all of the heat distribution water through the buffer tank. Never a good idea. That just becomes a wide spot in the pipe, where the whole idea of having this buffer tank is being able to fill it with heat and then inject that heat into the distribution system as needed in different ways. We can use an injection pump, or you can use a three-way valve, different setups, and more technical than we can talk about right now, I think. But there are a number of different ways of setting these up, especially multiple tanks. Sometimes we do multiple tanks because you don't have enough space for one giant tall tank, or can't even get it in the door. So you put multiple 3-foot diameter tanks in side by side. You know, there's all these plumbing questions as to how that gets done. And Scott can help with that. And that, again, is part of our expertise as well at Froling.
I really appreciate it when an engineer will send me plumbing diagrams so that I can take a look, especially at that tank setup, because I've seen it done incorrectly too many times. And there have been many times when just a slight plumbing change with the same equipment would have made a huge difference in the way the system operated. So that expertise is available for free. We never mind when folks reach out.
Yeah, same here with our, if you're consulting with us on a project, we might even ask Scott then and pass it on. But Mark Froling has a lot of experience on this kind of stuff too. So that's good. It's always available. The commissioning procedures, Colette has asked about that. And I wonder, just tell us about commissioning on maybe the different boilers. What generally what happens in commissioning?
It depends on the site, Colin. Where we have an experienced dealer on hand, those guys usually can commission the boiler with their eyes closed. And they're on the smaller boilers, the T4 on down, those boilers, as long as everything is running, they will burn correctly automatically. Using the oxygen sensor and the thermometer in the stack, those boilers are able to tune themselves. When it comes to a big boiler like the TurboMat, we actually bring the Austrian folks here from the factory twice. We bring them here to help set up the boiler, to help build it out. Then they leave for 3-4 weeks, however long it takes for that system to be completed. And then an engineer comes back and spends a whole week with that boiler, operating the boiler, making sure that all of the various motors are working and working the way it should. And so that is something that we feel is very important. Froling Austria would not have it any other way. And that is always part of the price of the boiler when we sell it. There is regardless of the type of the boiler, there is a commissioning checklist that we offer. It's rarely used, to be honest. We also have the ability to connect a computer to the boiler, so we know all the settings that it had when it was set up. And if something goes wrong, we can refer back and we can say, hey, that didn't work, or that wasn't right, or next time do X, Y, Z. Unfortunately, a lot of these boilers are installed without that level of service and expertise, but it is available, and I wish it was used more. It would help us and our customers a lot more.
That's really good. Yeah. Here's another question. It says you refer to, no, wait a second. Let me see. Did you certify your boilers for the new?
Here, if you can hear me.
Oh, there he is. Khaled.
Scott,
Go ahead.
sorry.
Sure.
Yeah. quick follow-up here. So Scott, would you issue a boiler warranty even though the commissioning checklist wasn't completed?
It would depend on the boiler and the situation at hand. One of the nice things about Froling boilers is that there is a lot of data being tracked internally by the boiler at all times. For instance, we know how many start-stop cycles the boiler has. So we can see that if there is a boiler with a big storage tank, an adequately sized storage tank, that is turning on and off too frequently, we know there's a problem with the installation. Same with a cordwood boiler. If the cordwood boiler has excessive slumber hours, basically time when it has nothing to do but a full load of wood in it, we know that it's not being used correctly or it's not installed correctly. We can see how many ignition hours there are. We can see how many times the grate has been cleaned. We can see how long the vacuum tried to run to add fuel. You name it, we can see that. So it's not as good after the fact to figure that out and tell somebody, look, there's no warranty coverage. But that doesn't happen all that often, to be honest with you. In fact, it almost never happens. So at this point, we are not the iron fist. We are more trying to encourage people to do things right in the beginning. But luckily, the boiler technology is pretty great and protects itself pretty well. In many cases, actually, if things are really bad, the boiler simply won't operate, and we'll get a call pretty quick. So, yeah, it's not like the olden days where somebody could put a boiler in that would make a bunch of black smoke and fill a neighborhood with smoke. The boiler just won't operate like that.
Do you require having an internet connection so you can look at the boiler anytime you want or get alerts, or are some boilers off the grid?
We do not require that, and I don't think in my lifetime I ever would. I don't believe that I should have the ability to look into my customers' homes and businesses and buildings. That's not for me. If they want to give me that access, then I am happy to use it when they need me to use it. But no, I'm not. I guess I'm not in favor of that at all.
Do you ever need to do any firmware or software updates to the boiler algorithms, or that's not needed?
Occasionally we do those. At this point, that is done on site with a direct connection.
Okay, thank you.
You're welcome. Good questions, by the way.
Thank you. Sorry, Jim, for interfering here, but I figured, easier to speak with. Scott, good to see you, Scott. It's been a long time.
Yeah, you take care. Yeah,
stay here. I lost a few hairs.
Oh, my. Well, Khaled, you also, I was going to read your question right when you jumped in, and it was another question. It was, did you certify all your boilers for the new EPA regulation? And then what is the schedule for the forthcoming 250 kilowatt boiler?
We did not get all of the boilers EPA approved. We approved all or are going through the process right now with all residential boilers and some of the small, what we consider small commercial boilers. We do not believe we are going to try to get EPA certified for the T4 boilers. They're too big for residential tests and too small for commercial tests. We're in no man's land with EPA testing with regard to those boilers. There is no method that I'm aware of that will be able to test them, which is a major problem. And at this point, there is no EPA certification required for those boilers in any state that I'm aware of. The T4 150, the soon to come 250, the the TM 500 may require emissions approval, site approval in some states, but I don't know which. To answer the question about the T4E 250, we expect that to be ready in the 2021-2022 heating season.
Okay. That's
And
a
the
good size.
T500, the T500 is special because it's over 1 million BTUs per hour. Is that why it requires a special approval, while the 250 is not?
Well, it depends on the state, and
Okay.
each state has a different threshold for commercial boilers. I think in New Hampshire it might be 2 million BTUs per hour, but I'm not sure about that.
It is input 2 million BTUs, right?
Yeah.
Which 1.7 is just perfect for that typically.
Yeah, we're right on the border.
Yes, you are. Mm-hmm.
But I had extensive conversations about testing the T4, both with EPA and with a regional air testing company. And what I found was that the EPA labs, the residential labs, just can't handle a chip boiler of that size. But the stack for that boiler is not big enough for the instrumentation that they'd use for in situ stack testing. Mm-hmm. So we're in a, as I say, a no man's land testing wise.
What we find with our with testing and let's say viability of a boiler system in New Hampshire in particular, when somebody has a boiler such as the 500 size, 500 kilowatts, which would be the 1.7 million BTUs. Again, they're under the radar, but the DES, in order to do thermal recs in New Hampshire, that's a special thing that you need to get approval. And so we need to qualify it, but New Hampshire accepts the European test results when there's a boiler that they're wondering what's going to happen here. You know, other states aren't going to be quite so accommodating. They'll demand the EPA result, which puts us, again, that sort of no man's land idea. Thermal recs, I have to go through the New Hampshire DES, so they'll run through the paperwork and decide whether this is a viable boiler or not. For other purposes, we're under the radar, but, you know, Scott, I don't know if somebody had a T4 they wanted to put in, and they didn't care about thermal recs or anything like that. I don't know what regulation, if they weren't going for a rebate or anything like that, what do they have regulations they have to meet, or is it simply under the radar?
The only state I'm aware of with a regulation is Vermont. They dropped a regulation about 2 years ago now, because after the EPA said well, it may have been longer than 2 years ago, but at some point Vermont said no more commercial boilers unless they're EPA approved, period. Because what happened is after they started regulating outdoor wood boilers at the residential level, the outdoor wood boiler companies, the unscrupulous ones, started selling them as commercial boilers. They were sold to residences, and Vermont residents were issuing complaints to the Air Division. So they just said all boilers have to be EPA approved, and I went to them and I said, I can't do this. You have this really admirable renewable energy goal, but you're eliminating a whole class of heating products with this EPA requirement that cannot be met by boilers such as the T4. They listened and they came up with a special approval process. We paid $1,000. They checked all of our European test documents and they issued an approval. And I believe to this day, the T4 is the only boiler in that size class that's approved in Vermont.
Yeah, that's a good one. Here's another question that Bart Bales asked, and it's, you referred to condensing pellet boilers. Doesn't that have a higher turndown ratio? And in the condensing boilers, how are you managing to condensate? What is the sulfur content of wood versus oil? Multiple questions there.
Yeah, I don't know what the turndown ratio is of that boiler, but I don't believe that it's condensing necessarily because of its turndown ratio. I believe that it's condensing by having excess heat transfer, heat exchange surface, which is lowering the stack temperature adequately to condense the exhaust. I also don't think that boiler is going to work in an American baseboard distribution system. You know, that system is designed to work with low temperature distribution just the same way any condensing gas boiler is in the United States. So I would say turn down probably doesn't change, but I can't swear to that. It's just excessive heat transfer surface. I'm sorry, the last question, the last
Condensing, how do you manage the condensate, Scott?
Oh, so that condensate is basically laden with fine ash, and as I mentioned, that ash is washed off the heat transfer surfaces with a sprinkler, and the resulting muddy water is sent to the drain, and that is why I don't believe that technology is necessarily ready, although there are plenty of companies doing it in Europe. I just don't, to me, it's they're burying their heads in the sand about the downstream problems that's going to create. So when I asked Froling Austria how they manage that muddy water and does it cause problems in traps, drain traps and such, they did not have an answer for me. So I don't. To me, it's a great incentive filling item. If Germany wants condensing boilers, the manufacturers will make them. In the U.S., companies like Main Energy Systems have introduced a condensing boiler. To me, it's marketing. I could not sell that in good conscience to one of my customers without knowing how to deal with that muddy water.
I think it's a product looking for a market too. I think that's part of their experience at Main Energy is they'll say something about that next week, I'm sure. But it's hard to find somebody that can actually use the condensing that wants a pellet boiler, and it sounds like a great idea. But most everybody has like baseboard radiators, and you know it's and a lot of times when you get a brand new house with radiant floors and such, there's such little heat loss. The pellet boiler's not even all that valuable, and you know, why go to the extra expense of the condensing boiler anyway? There's so many different little variables, and here we are trying to sell product and stay in business, you know, and it's hard.
It's sort of like residential CHP. Great marketing scheme, really interesting, grabs a lot of attention, almost zero applications in reality.
Yeah. Yeah. Here's one more that it says, what is the sulfur content of wood versus oil? Which might also say, what kind of other interesting things are coming out of a stack from a wood boiler, from a pellet boiler, say?
Yeah, so there's almost no sulfur in wood smoke. If a tree has grown where there's heavy sulfur, perhaps you're going to get some sulfur, but that is one of the major differences between wood energy and any of the fossil fuels. There's much less sulfur. That's why in New York State, they've gone to ultra low sulfur fuel because they knew that was the only way to condense oil systems, one of the reasons. And because if you condense oil that has 500 parts per million, you're going to make an acid mess in the exhaust. So you don't have to worry about sulfur with the wood ash at all, as far as I know.
That's good. Okay. Well, we've gone a long time here, and we've still got a number of people here. Here's one other question or one other comment, which says, I would think the place for a condensing boiler would be in the larger boilers, if not sulfur. What do you worry about? 2 questions.
I worry about, so I don't know. I don't know whether condensing would be interesting in the larger boilers or not. Potentially it would be. But we find that many commercial systems operate with high temperatures, actually, and I'm not sure how many of them are supplying a return that's cold enough to condense. Great question that I don't have a complete answer for. Apart from sulfur, I only worry about mud in the coming out of the drain for the condensing system. And I worry about the extra expense. You know, these condensing boilers are not cheap. And sometimes what happens when companies are incentivized to offer this type of equipment, a false market is created. People get excited about a technology. There seems to be a moth to the flame mentality where all the regulators and program builders and bureaucrats start to say, they offer this technology, now it must be the greatest thing. We're now going to require that everywhere because it's BDT, it's best demonstrated technology. When the fact of the matter is that that technology is really, it may be BDT, but it's not market ready. It may be market possible, but it's not a true market product. It cannot exist without incentives. It may not exist in the long run. It may not be a direction we want to go. So I always get nervous about products like CHP condensing biomass boilers. Even the internal ESP makes me a little nervous. We offer these products because somebody is offered a hoop to jump through, and then we jump through the hoop and there's no going back. We see this collide with New York State. I know the intent is to drive the technology forward and make it cleaner and cleaner, but part of the problem is that we end up with equipment that is super expensive and difficult. And we could have had technology that was much less expensive, much easier to operate, much more reliable, and that would have induced people to change from old equipment to newer equipment more readily. So we sort of bite the hand that feeds us sometimes, or I guess it would be the reverse of that. The hand that feeds us slaps us or something like that. But I don't know if that answers your question sort of in a roundabout way. I guess it does.
Okay, well, hey, if there's any more questions, we can jump to them. But and you can also open your microphone if you've got something more.
If you don't mind, I have one more question.
Sure.
Scott, I liked it when you said that you appreciate it when the engineer shares piping schematic with you regarding the boiler install, the tank install. This, to me, it's more of a commissioning necessity, not just something you would appreciate. But my question is that in your boiler sales, how many of them do you actually go to the site to discuss with the owner and the design engineer the best way to situate the boiler and the tank? So this way you got your eyes and ears on the install itself, where the silo is, where the boiler is, where the tank, any cyclones, to kind of get a better feel of where your boiler is going to be installed, as opposed to just shipping a boiler to the site. What's the recommendation and how do you typically do it?
We work very hard to sell through dealers. When we began with Froling Austria, that became one of our main goals. We knew that the product was great, and we also knew that it would not be realized as being great in the field unless it was properly installed. So a huge number of our sales are through trained dealers who are installing. We do not see everything we sell. Sometimes we see jobs that are gorgeous that we had no idea ever happened. The photos I shared with you today of that greenhouse application, I'd never seen it. You know,
Okay.
Froling Energy said, we need a boiler. Here's the basic drawing. I submitted that drawing to Froling Austria. They came back to me with a schematic to scale so that they knew exactly how to build the feed equipment. I gave them a price. We sold the boiler. Froling Energy installed it, and they did it right. And Jim sent me the pictures the other day, and he said, my gosh, it's beautiful. And you know what? It works. The system works. So yeah, it's about having trained people around the country. And we can't possibly, at $40 per barrel oil, have these people everywhere. There's just not enough demand. But it's a main emphasis for us, and also for some of our competitors. We try not to sell direct.
I appreciate that, and I think you bring up good points, and your answer is very practical. We were putting high precision steam flow meters in one of the installations, and actually the steam flow meter manufacturer, a German one, would not even sell us the equipment without having a detailed engineering drawing showing the upstream and downstream pipe diameters, because they have gotten so many headaches of people blaming their equipment that's not working, but actually the install was the problem. The equipment was perfectly fine out of the box, and they had like commissioning checklists and all that stuff. That's why I bring up these points, because I investigate a lot of installs, and sometimes it's not the equipment's fault, it's the installation fault, or the engineer's fault, or the contractor, or the commissioning, or the balancing, or the control sequences. So that's why I try to get the teams together as much as I can to talk to each other to be able to have a better install. So thank you for your answer. I know you're practical, and I know that there is limitations all the time.
That's good. That's good. Yeah, that's, as a dealer, I'll just say that we deal with a lot of engineers. We rely on a number of specific engineering firms. On a big project, we'll go in as a team, and we'll rely on their expertise for designing the layout of a boiler room. Usually there's fairly big projects. There's a lot of experience on my own crew, and they all put their heads together. Sometimes there's a little bit of work done just as the installation begins. So there's a lot of different real world kind of things, and they'll all put their heads together and call somebody else. But it's usually fairly predictable, and then it's a matter of sticking with it as well. I think your comment about control sequences, that's something that we run into. It's the building control system, the management system, that's actually screwing up the boiler. It's treating it like an oil boiler, or it's somehow reprioritized things and has the oil turn on, or there's all sorts of possibilities there. So people need to be open to discussion after the fact. Not everything's perfect immediately, and you have that time frame not only in the first few months, but then as years go by, we maintain these boilers. We come in and do cleanings, and then we'll be the warranty guy, the service guy, an annual tune-up, those kinds of things. Pretty important stuff as it goes along, and suddenly things can change. They got a new building management system, and whose fault is that? Well, it's just something to think about. So. I wanted to tell you that I want to thank Scott, by the way. Just thank you so much for doing this. It's been educational for me as well, especially on these new products. We've had a great experience with Froling boilers all the way around. And I just thank him for his time spent today. This will be good. Well, this will be recorded, by the way, and we will post this on our YouTube site. You'll see that here again. You just go to YouTube and search for Froling Energy Biomass Systems. It'll comes up pretty quickly on that, and you'll see this list right here. If you go down to this, you'll see these are the 3 biomass fuels. This is that particular webcast, so you'll learn a lot about that. But there's also sustainability and air emissions and different other boilers and different kind of. I think they're very interesting because I'm kind of a biomass geek, I guess, but they're I think you'll find them very enlightening. And next week, again, we're going to do the main energy boilers, which are pellet boilers, and a product that's been very popular. So that's good. We hope to see you there. If you have any questions, please give me a call, or you can send an email. If you'd like to have a transcript, I'm sure a transcript, I should say, a PDF of the slides. I'm sure Scott could provide those. So you can send an email to me or to Scott directly. So thank you, everybody. I'll wind this up, and we say maybe we'll see you next week.